Hey guys, so today we are continuing with graphing our log functions and finding their key attributes or characteristics. So as you can see, I'm going to be doing the right side today. I'm going to be doing all of the evens because these are the more difficult ones in my opinion. And then you all will be doing the odds today. So we've already discussed how to find each of these parts, so we're going to continue with what we've already done last week. So if you do need a refresher, there is the video posted from on, I believe it's Friday. Yes, so there's a video posted from Friday that goes over how to graph these log functions, and then we're going to be doing it again today and tomorrow. Yes. Okay, so we see that there's two transformations that are occurring. We'll go more in depth with the transformations tomorrow, but I like to take them out just out of habit. So we're going left 5 and down 5. I get my domain and my asymptote from in here. That left-right movement tells me where my domain and my asymptotes are. So remember, on the inside of parentheses, we're going opposite. So really, we're dealing with a -5. So my asymptote is x equals -5. So this is the line that I'm going to get close to but not touch. And so my domain will be everything greater than -5. My range, of course, is going to be all real numbers. And then to find my x-intercept, we're going to plug in a 0 for y and solve. Any log that we don't see the base is a base of 10. And add that 5 to the other side. We get 5 equals log base 10 of x plus 5. If you need to see it with the log written first, that's log base 10 x plus 5 equals 5, which we've got first, last, and middle. 10 to the power of 5 is equal to x plus 5. Subtract 5. And 10 to the power of 5 minus 5 is our x value. So 10 to the power of 5 minus 5 is 99,995. And then since it's an x-intercept, comma 0. So that's way out there on the x-axis. It's nowhere near what we can see on our graph. So we're going to take our original starting point from the parent function, which would be right here. I'm going to take that point, and this is why I like to take out the transformations. Let me put it in a different color. Because then, when I have the transformations, I can just move them. So I'm going to go left 5 and down 5. And that's now my quote-unquote starting point. The other point that is on the parent function is 10, 1. And we can't see that on our graph because our graph only goes out to 8. So if I go left 5 from 10, I'm at 5. And then down 5 from 1. 1, 2, 3, 4, 5. So this side gets close to the asymptote. This side goes through that point and keeps going up. So that's what our graph would look like. And then we've got all of our parts written in. Number 4, same deal. So we get the domain from the inside there. We take the opposite. And that's also our asymptote. So x equals -2. Pull those transformations out of there. We're going left 2 and up 1. Range, of course, all real numbers. Let's find that x-intercept by making y a 0. Log base 10, x plus 2 plus 1. Negative 1 equals log base 10, x plus 2. I'm not going to flip it this time, so this is 10 to the negative 1 equals x plus 2. So we converted it here to exponential form. 10 to the negative 1 is 1 over 10. And then we'll subtract 2. So 1 over 10 minus 2 is equal to x. So 1 over 10 minus 2 is negative 1.9. So that's where our x-intercept occurs. We're going to take that original starting point of 1, 0, move it to the left 2 and up 1. Original starting point, well, continuing point of 10, 1, we move left 2, is now at 8 and up 1. And we're getting close to that asymptote. We've got our graph sketched out and all of our information on the right there, so we're done. Number 6, opposite of what's inside. Range is all round numbers. To find the x-intercept, we solve it equal to 0. Add 3. Convert. So 10 cubed minus 4 is what our x value is, which is 996. So again, we're way out there on the x-axis for where we're going to be crossing. We know our we know our asymptote occurs where x is negative 4. We're moving left 4 and down 3. So we're going to take that starting point, move left 4 and down 3. And then left 4 from 10 is 6, down 3 from 1 is negative 2. Number 8, take that domain and asymptote out of the parentheses. X is greater than 1. Remember, we're looking at the opposite on that inside there, so we've got a positive 1. Range is all round numbers. X-intercept we'll find. Add 4. Convert. And solve. 10 to the 4th plus 1 is 10,001. Can't have that comma there because of the 0. But it's 10,001 comma 0, so again, we're way out there. We're not going to be able to see that x-intercept on our graph. If we could zoom out, we would see it then. So we're moving to the right 1 and down 4. So we're normally at 1 already, so if we move to the right 1, we're now at 2, and then down 4. And then The next point we won't be able to see because it'll be at 9. Well, it'll be at 11, sorry. Move to the right. Next one, we're moving to the right again. And down 5. We take the domain and the asymptote from the parentheses. So x is greater than 1, x equals 1. Range is all real numbers. Solve the log equal to 0. Add 5. Convert. Solve for x. 10 to the 5th plus 1. And get 100,000. I keep putting a comma, that's gonna mess me up. Sorry. 100,001, comma 0. Our asymptote, which is normally on the y-axis, is going to move to the right one. That point we normally start with is going to move to the right one and down 5. Close to the asymptote. We won't see the next point. And lastly, number 12. We're moving to the left 6 and down 5. Domain, x is going to be greater than negative 6. My asymptote is at negative 6. Range is all real numbers. Solve our log equal to 0. Add 5. Convert. Solve for x. 10 to the 5th minus 6, which is 99,994. So again, that's way off of our graph. We're going to take that point 0, the 1, 0, move it to the left 6, and down 5. Take our other point at 10, 1, left 6 would be 4, down 5 would be negative 4. So then those are all of our graphs. We've identified all the key characteristics on each, and then so you guys will do the odds and then turn that in on Canvas.